All right, my beautiful mathematicians, we've got warm up 4 from the 2023 problem set. Here we go. You know the drill. Try the problems out yourself if you haven't already done them. Pause after I've read the problem, and then you can unpause to see how my solution goes. On a 100 centimeter stick, Cecilia makes a mark at 12 centimeters, n centimeters, and 72 centimeters, measured from the left end of the stick. The distance between the marks of n and 72 is 5 times the distance between the marks of n and 12. What is the value of n? All right, so we've got 12 over here, n in the middle, and 72. So if I want the distance between these two values here, I would do 72 minus n. If I wanted the distance between 12 and n, we would do n minus 12. The larger number minus the smaller number. Okay, so in this instance, it says that the distance between the marks of n and 72 is 5 times the distance between n and 12. So this is a bigger distance than this one is. If I want these two to be equal to each other, I'm going to have to multiply this one by 5. And now we have an equation that we can solve to solve for n. I would distribute first over here. So I have 72 minus n equals 5n minus 60. I'd add n to both sides. 72 equals 6n minus 60. I would add 60 to both sides and get 132 equals 6n. And then I divide by 6 on both sides. And I get, what, 22? Yep, 22. There's our answer. Number 62. Half of Madeline's coins are nickels and half are dimes. If the total value of Madeline's money is $1.95, how many nickels does she have? Okay, so there's a bunch of different ways we could do this one. Probably the easiest way is to realize for every dime, she has to have a nickel. So they're always matching up. And so a dime and nickel combination is worth 15 cents. She's always going to have things in groups of 15 because she has one dime for every nickel. So all I have to do on this one is see how many times 15 goes into 195. So 15 goes into 19 once with 4 left over, and 15 goes into 45 3 times. So she has 13 combinations of one dime and one nickel. So how many nickels does she have? She has to have 13 of them. She has 13 nickels and 13 dimes. Katie is driving at 50 miles per hour. If a mile is 5,280 feet, which it is, and a furlong is 660 feet, who uses furlongs, and a fortnight is 14 days, how fast is Katie driving in furlongs per fortnight? Ugh. Okay, so we've got a dimensional analysis problem here. We're starting with 50 miles for every 1 hour. Eventually, we want furlongs in the numerator and fortnights in the denominator. So let's go ahead and do some conversions. We'll start by getting furlongs in the numerator. So there are 5,280 feet per mile. So my first conversion is going to be 5,280 feet per mile. Now what that does is it reduces miles, and now I'm in feet per hour. I need furlongs in the numerator, so I need one more conversion. A furlong is 660 feet. So 1 furlong is equal to 660 feet. I put 660 feet on the bottom because now the feet reduce, and I am now in furlongs per hour. I want furlongs per fortnight. and a fortnight is 14 days. So let's convert hours into days now. Ugh. So I want days on the bottom. 1 day is 24 hours. The hours have now reduced. I am now in furlongs per day. I want furlongs per fortnight. So 1 fortnight is 14 days. So now the days have reduced. My units are now furlongs per fortnight. That's what I want. And now I've got this big old problem. And notice this is a non-calculator problem. So reducing is the biggest trick for this one. All right, I've got 660 that I can reduce with all these numbers. The first thing I'm going to reduce is I see a 0 here and a 0 here. So I'm going to reduce those by 10. And now I've got 66 here and I've got 5 here. Okay, now I've got 66 and 24. I notice that 6 goes into both of those numbers. So 6 goes in here 11 times and 6 goes in here 4 times. Now I've got 11 and I have to ask myself, does 11 go into any of these numbers? And it does. Now I don't know if you know the rules for 11s, but if I look at 5280, if you look at every other number, here we've got 5 and 8. 5 and 8 is 13. And then on the other side, we've got 2 and 0. So 2 and 0 makes 0. I'm just adding the digits. And if I find the difference between every other number, the difference is 11. If we get a difference of 11 or 0, 11 has to go in that number. That's the rule of 11s that's the divisibility rule for 11s. If every other number, if you subtract every other number and you get a value of 11 or 0, 11 has to go into this number. So I know 11 goes into 5280. I just have to figure out how many times. So 11 goes into 52 4 times with 8 left over. 11 goes into 8 times, and then we still have that 0 there. Okay, so what am I left with? 5 times 480 times 4 times 14. So I've got 5 times 4, 20. 20 times 14 is 280. So now I just have to do 280 times 480. And then once I do that multiplication, I have my answer. I'm not going to do it for you right now. I already did this earlier. The answer ends up being 134,400. Next, what is the maximum number of 4 by 8 by 2-inch tissue boxes that can be packed inside a 16-inch by 20-inch by 10-inch carton? So you might be tempted to find the volume of this one and just find out how many times the volume goes into this, or this volume goes into that one. We do need to check first that these can fit in here evenly, because every once in a while on a problem like this, we can't fit one size into the other size evenly. And there's an easy way that we can check this, is if we can match up each of these numbers to be a divisor of each of these numbers, then these will fit in here evenly. And here's what I mean by that. I can see that I've got 8, and that goes into 16. So 8 goes into 16 twice. And then 4 goes into 20. And then 2 goes into 10. So since 8 goes into 16, 4 goes into 20, and 2 goes into 10, I can tell that these tissue boxes can evenly fit into this carton. Now, if we had a situation where maybe this last number was 9, we would have not been able to fit them evenly in there. We would have had like a little leftover space inside the carton. But we don't have to worry about this, luckily. So now we can just reduce. 8 goes into 16 twice. 4 goes into 20 5 times, 2 goes into 10 5 times, 2 times 5 is 10, 10 times 5 is 50, 50 tissue boxes can fit in there. Next one. What is the value of 2.25 plus 1.5 squared plus 3 halves squared plus 1.5 squared? When we've got all these numbers all different, it's probably easier to turn this into improper fractions. So 0.25, that is a fourth. So how many fourths is that? That's 8. That's 9 fourths. 1.5, that's 3 halves. And then 3 halves squared, 3 halves times 3 halves is 9 fourths again. 3 halves squared, again, 9 fourths. 1.5, that's also 3 halves. Oh, so we've got 9 fourths plus 9 fourths plus 9 fourths plus 9 fourths. That would be a total of 36 fourths, which is 9. Next, how many digits are in the binary, base 2, representation of the decimal base 10, number 2 to the 4th power? Okay, so base 10, we have to realize that our counting system, the units digit is represented by 10 to the 0 power. So that's how many ones we have. And then the tens digit is 10 to the 1st power. And then this one is counting how many hundreds we have, which is 10 to the 2nd power. And then this digit is counting how many thousands we have, 10 to the 3rd power. But if we are in base 2, binary, the first digit is 2 to the 0 power, so they're counting the number of ones that we have. The second digit is 2 to the 1st power, so we're counting how many 2's we have. This digit is 2 to the 2nd power. We're counting how many 4's we have. This digit is 2 to the 3rd power. We're counting how many 8's we have in this digit. And then this digit way out here is 2 to the 4th power. This is counting how many 16's we have. So the number 16 would be represented by 1, 0, 0, 0, 0 in base 2. So how many digits are there for 2 to the 4th? 1, 2, 3, 4, 5 digits. Next. Two integers with a sum of 36 and a difference of 16 have an LCM of A and a GCF of B. What is the value of A minus B? So what's the value of the LCM minus the GCF? Well, first of all, we need to find our two digits. So it says the sum of the digits, we'll just say x plus y, is equal to 36. The difference of the digits, we'll call that x minus y, is equal to 16. Okay, so what we can do is we can add both sides of the equation together. Since this side equals this side, I can add this side to that and this side to that because they're the same amount. It's just written different ways. So if I add these two together, I get 2x, the y's cancel, and then over here I get 52. So x must be 26. Now, if x is 26, I can plug 26 into either one of these equations. 26 plus what is 36? 26 plus 10 is 36. And it still works over here. 26 minus 10 is also 16. So my two values are 26 and 16. Okay, the LCM, the least common multiple. So I'm looking for the smallest number that both of these will go into evenly. And we'll look at the factors of this. 26 is 2 times 13, and 10 is 2 times 5. So in LCM, we have a 2, and then we have a 13, and a 5. I didn't need two 2's here because they shared a common factor. So we find the common factors, 2, and then any leftover factors we multiply. So 2 times 13 times 5, that's 26 times 5, ends up being 120. 30, right? Yeah, 130. Yeah, losing my mind. So the LCM is 130. All right, the GCF. What's the biggest number that goes into both of these? Well, over here, the GCF is the common factor of 2. So 2 goes into both of these. So A is 130. The GCF is 2. That's B. So 130 minus 2, 128 is our answer. Next. The graph shows the number of hours Cherish slept each night for a month. On how many nights did Cherish sleep for less than 8 hours? All right, so you just have to know how to read a graph on this one. Here's the hours of sleep. So we want everything on this side of 8. And then this is the frequency over here of it happening. So this is 5 and 5, that's 10, plus 2, 12, plus 1, plus 1. It looks like a total of 14 nights. That was nice to have an easy one. All right. What is the length of the line segment AB with endpoints 0, 5 and 4, 2? Okay, so for this one, what we just need to do is look at the difference in the y values and the difference in the x values. So our y values are vertical. The difference between 5 and 2 is 3. And then now I'll look at the distance of my x values, 0 to 4, that's a distance of 4. And so the distance between the 2 points would be this connection right here. And what we have is a right triangle because I have a vertical distance of 3 and a horizontal distance of 4. So we've got a right triangle. So at this point, you have 2 options. Either you know your Pythagorean triples. This is a Pythagorean triple. It should be a 3, 4, 5 triangle. Or if you don't know your triples, then you can use the Pythagorean theorem, where a squared plus b squared is equal to c squared. So anytime you have a right triangle, you can take 3 squared plus 4 squared. Those are the 2 legs. And it's always equal to the hypotenuse, this diagonal line here, squared. So this is 9 plus 16 equals c squared. 9 plus 16 is 25. And I want to find c, this length. So I have to undo squaring, and the opposite of square root, or as squaring is square root, so the square root of 25 equals 5. All right, last one. If x star y is the function 2x over y squared plus 1, it's not a function, is it? Anyways, 2x over y squared plus 1. For what value of x is x star 3 equal to 7? Okay, so all you have to realize is x star y is a set of operations that's equal to this. So whatever x is, you plug in here. Whatever y is, you plug down here. So this is the y value right there. I don't know the x value. So I'm going to write 2x over, and then y is 3. So I'm going to do 3 squared plus 1, and that should equal 7. And now I just have to solve that. So on the bottom, I've got 9 plus 1, that's 10. I can now multiply both sides by 10 and get 2x is equal to 70. Divide by 2, and x is equal to 35. Boom. Done. Keep mathing hard. I will see you next time. Bye-bye.